Okay, so continuing with our Chapter 1 notes, our section on math review, we're going to look at linear equations. And hopefully this is nothing you haven't seen before already. In fact, hopefully y equals mx plus b, this wonderful equation right here, should look pretty familiar to you. And again, remember, in physics we're comparing two things. We're comparing one value to another value. We're comparing, in this case, x to y. Or that means that that y, whatever y is, depends on whatever x is. And then we have this multiplier out front. You probably know that to be the slope of the line. And then this plus b is another, basically, y value that determines where where the line intersects the axis. So y is our dependent variable, depends on x. Okay. X is the variable that well, we're given. It's the independent variable. M is the slope, of course, and b is the y-intercept right here. So this y equals mx plus b, this multiplier out in front of the x, is going to be our slope, and the b is going to be our y-intercept. Let's take a look at that. If your slope is positive, that is, if it's greater than 0, in fact, I'm just going to put a plus right here. Going from left to right, it will go up. It'll go like, kind of like that. If it's negative, it'll go down, reading from left to right. And if there's no slope at all, if the slope is 0, then the line will be flat. Like, if you're on a ski slope and there's no slope, you're flat. You're not going to go anywhere. So if we're solving for one unknown or another, all we do is we reverse operations. If something's being subtracted and we want to undo that, then we add it. If something's being divided and we want to undo that, then we multiply. And that's how we rearrange equations to solve for what we want. All right, let's take a look at this right here. Here we have an equation you'll become very familiar with a little bit later on. But in this case, we're going to want to solve for t. All right, let's just say right now, I don't want to do that. We want to solve for the t. All right, now I'm going to tell you right now that what some of these variables, that is what roles they play. We're going to say that VF is going to be the dependent variable, okay? That depends, just like Y does, depends on something over here, okay? T is going to be the independent variable, all right? Independent means it doesn't depend on anything else. T, which is actually time, just rolls on whether something else is happening or not, so T is going to be our independent variable. Since we've got this multiplier out in front of the t, that's going to take the place of the m, or the slope. All right, so that g right there is going to be the slope. Come on now. I'm trying to draw next to g. It's not working, is it? All right. Slope. Not working at all. Last time. S-L-O-P-E. Sorry about that, guys. And this thing is being added right here, this VI, that's going to take the place of our B, that is our y-intercept, okay? Y-intercept. Well, as it looks right now, it's not very pretty. It's not very in the y equals mx plus b format. But let's put it in that format, all right? So if the y, or the dependent variable, is VF, then we're going to put that out front, VF. And that's kind of what we had so far. Okay, good. Our mx, well, that takes the role of the gt right here. Okay, and I'm going to put this in parentheses right here because it's a minus g. Let me undo that. Let me reset. It's a terrible g. The negative g times time, okay, or times t, plus whatever's left over plus what acts as our y-intercept, that is our v initial right here. Okay, and that's what we have right there. So let's solve for the independent variable, solve for that t right there. First thing we need to do is we need to get this vi away from everything else. So we're going to add that to both, or we're going to subtract it to both sides. Since it's currently being added right here, let's subtract it. Minus vi, so that becomes 0 and goes away, but that means we need to have a minus vi on this side. Vi. Okay, so it's going to be v final minus vi, v initial, equals minus or negative gt. Okay, now we have this, we need to get the t by itself, we have this negative g out in front of it. It's being multiplied currently, so we want to divide to undo it. So it's divide by negative g, which means, of course, we're going to need to divide by negative g over here. And so our final expression for solving for the independent variable, which I told you is t, is going to be t equals v final minus v initial over negative g. All right, so we're just rearranging equations by undoing whatever is done to whatever variable we're working with. So let's say we have an unknown in the denominator. Okay, we cross multiply, or sometimes you could say we cross divide as well. For example, let's say we have, I don't know, 2 equals 3, over x. Okay, 2 equals 3 over x. This x right here, we want to solve for this. First of all, it's with this 3, and secondly, it's in the denominator, which we never want it. We want it by itself in the numerator. So on this side, it's being divided, so we're going to undo that division by multiplying. You could call that cross multiplying. So in this case, that x would come up here because we're multiplying on this side, so it goes away, which means, and you need to multiply over here on the left-hand side. So we'd have 2x equals 3, and then of course you say, okay, great, you've got the x in the numerator, but you need to get that 2 away from it. So it's currently being multiplied, so let's undo that by dividing. Let's divide by 2, which means we've got to divide by 2 over here. So essentially, the x comes down, or the 2 comes down and across. Basically, whenever you cross over the equal sign, you move something from one side of the fraction to the other. For it being divided over here, you move it across the equal sign, now it's being multiplied. And vice versa. So let's get this, let's solve for t1 right here. It's currently in the denominator over on the left-hand side, and we don't want it there. So, in fact, let's get everything out of the denominator. If we're going to cross it over the equal sign, or we're going to bring it up into the numerator, it's got to cross over the equal sign. Likewise, that t2, we're not going to want it there because it's going to be in the denominator once we bring the t1 up, so we're going to move that up as well. Okay, so it's going to be t2 times v1 equals v2 times t1, just like that. Okay, so we undid the dividing right here by multiplying. We would call that cross multiplying. Oops, cross multiplying. That's a cross, not an x. Okay, so we want to solve for now just this t1. Well, this v2 is being multiplied by it, so how do we undo that? Well, we divide. So the v2 would essentially come across the equal sign and down into the denominator. So a final solution for t1 is going to be t2 v1 divided by v2. That's our final answer right there. Again, you make a pattern right here. If you're solving for x right here, well, you got to bring it up to this side, but then you know, of course, that b's got to get away from the x, so you're going to want to divide it and bring it down to that side. So essentially, b and x trade places. Just trade, switch them around, so that means x equals a over b. So instead of doing little individual operations, okay, let's multiply here, and let's divide right here, you can just say, oh, I've seen this pattern before, and this is going to happen a lot. Just switch the places. Just switch them right there. It's like cross-multiplying and cross-dividing all at once. One more last little thing for you for the time being. Let's say we have a bunch of variables out in front of a bunch of different expressions right here. You can cancel them. Take a look at this, for example. This looks like a really big, messy equation, and it is, to be fair. But you'll notice there's an m here, and here, and here, and here. They all have the exact same thing in them. Now, what you could do, I guess, at first, you could factor out the m, but then you'd still have an m out in front on this side, and then you need to factor that out. You'd have an m out in front on this side. Everything's still being multiplied by m. So if everything is being multiplied by the same exact thing, you can cancel everything out all at once, and then you have a much prettier equation left over. So that'd be 1/2 vi squared plus ghi equals 1/2 vf squared plus ghf. Now, doesn't that look nicer? Well, at least it doesn't have the m's right there. But that's one thing you can do. You can cancel out variables, especially if they all have the same coefficient out front.